In previous session, we learned about embedding types and structures within the structures, pointers within the structure, anonymous structures, etc. As part of this session, we'll learn about advanced concurrency patterns, when to use, where to use, what are the advantages of concurrency, and go routines. Let us talk about Golang advanced concurrency patterns as part of this session. Here we have kind of 9 advanced patterns. Let's talk about worker pools. A worker pool is a common concurrency pattern used for executing a large number of tasks concurrently. In a worker pool, a group of workers is created and the tasks are assigned to them. Once a worker completes a task, it requests another task from a task queue. This pattern is useful for applications that require parallel processing of large sets of independent tasks. Second one is like a features and promises. A feature is an object that represents the result of a concurrent operation that has not yet completed. A promise is a placeholder for the value that the feature will hold once the operation is complete. A feature and promises are commonly used to implement asynchronous programming models, allowing the main thread of an application to continue executing while a long running operation is performed in the background. Cancellation. Cancellation is the ability to terminate a concurrent operation before it completes. It is useful in situations where a long running operation needs to be cancelled due to a user input or external factors. Select statements. A select statement is a powerful Go feature that allows you to wait for multiple channel operations to complete simultaneously. This pattern is useful for building reactive and event driven systems. Rate limiting. Rate limiting is the process of controlling the rate at which an operation is executed. It is useful for preventing resource exhaustion and regulating network topics. Fan out, fan in. Fan out, fan in is a common pattern in concurrent programming where a single task is divided into multiple subtasks that can be executed concurrently and the results are then combined to produce the final output. Next one is the context package. A context package is a powerful tool in Go for managing cancellations and timeouts across multiple Go routines. It provides a way to propagate a signal across a context tree and cancel all Go routines associated with the context. Select with timeouts. Select with timeout is a pattern that allows us to wait for multiple channels simultaneously and exit early if a timeout occurs. This pattern is useful when dealing with the external systems that may be slow or unresponsive, and we want to avoid blocking indefinitely. Pipeline. A pipeline is a pattern for breaking down a complex task into smaller stages and connecting them with the channels. This pattern is useful for building efficient data processing pipelines that can handle large volumes of data. Let us see each feature as part of programming, like how it works. Let's go with worker pools as we discussed worker pools. So here what we are doing is we are creating one worker function. It is basically trying to execute all the job IDs and results we are just writing into the results variable with the job ID with job actual job index. So what we are doing here is we are creating 100 jobs basically and results also 100 of channels and creating 3 workers. Right here we are calling worker method for 3 times and 9 jobs to be in the queue. We are just adding 9 jobs into the queue and we are trying to close the jobs and we are trying to get the result here. Let us see how it works. This code files I will share with you guys anyway. So if you see here we have like total 9 jobs, right, total of 9 jobs, and we have 3 workers and 9 jobs we are assigning to them to execute it, right? Worker 1, worker 2 and worker 3. 3 workers also got the opportunity to execute it, balance it, and worker 1 actually trying to handle one, job 4, job 5, job 6, job 7, job 9. Worker 2 got opportunity to handle job 2. Worker 3 got opportunity to handle job 3, like that. Okay. Next one is like a features and promises what we discussed in our discussion. Let me close all these things. So here actually we what we are doing is we have one method called compute a feature which actually try to sum the value of this the summation of like 1 to some 1 million, right? Long running task and the result we are returning here. So what we are doing here is we are creating the feature and a promise. We are just creating a feature here and we are initializing with that. And promise we are making just one channel and we are in this go routine actually we are waiting for the feature to have some value, right? Once this value is there then it will come out of this. Okay, so this is the very basic example code. So if you see this main thread, actually what happened, this is this came out of this, and it is trying to execute this particular method, this particular step. That means like the control is actually waiting for the result here, right? So we are waiting for result because we are trying to read out of this particular channel, this value. So the promise is actually executed, but the value of the process, the future is not yet completed basically when the control is here, right? So it is waited here to complete the future function on this result basically. So once this is done, then it is came out of that. So this is the value of the future, whatever we are summing of here 10 millions of indexes. And next, let's move on with the cancellation. Next section basically. So what we are doing here is in the cancellation, long running operation we are taking the cancel as a channel. Once you get the cancel channel, cancel is received, then we are returning from this cancel operation here. And by default, what we are doing here is we are trying to print this line, and we are sleeping for 1 second, right? So from the main function, we are creating one cancel channel, right? And we are writing one go routine to run the long running operation. And we are passing this channel here. And we are waiting for 5 seconds here, right? So and we are waiting for 5 seconds. After 5 seconds, when it reaches here, we are trying to cancel, I mean closing this particular channel. So that means it will come out of this particular long running operation. Basically, it will go and call this particular select statement. So we are returning here, right? Otherwise, by default, it is not returning. It is keep on executing this one. So basically, as per this particular, we are waiting for 5 seconds. This long running operation should print 5 times, and then we are waiting for 1 second, and then we're coming out of this main thread, right? Let us see like how it works. So in this case, if you see long running one time, second time, third time, fourth time, fifth time, that means 5 times we are sleeping, right? 5 times actually this particular select statement is repeated. And then once it came out of 5 seconds, then we are canceling this. We are closing the cancel channel. That means this will go and hit this particular case. In this case, we are returning from this particular infinite for loop, right? That's about cancellation. Now see the select statements basically how the next topic. Select statements. So here if you see we wrote very simple program here. We are created two channels with completion of each worker, right? And we are trying to call the go routines like two go routines here. One is 1 and 2. One particular worker one actually sleeps for 2 seconds. Worker two sleeps for 4 seconds, right? And then what we are trying to do here is we are trying to wait for these two workers to complete using the select statement, right? Let us see how it works. Select statements, right? So now let us run this one and see what happens. Worker 2 is working, worker 1 is working, right? Both workers got completed. That means we are waiting for this worker 2 actually took long time, right? It is working, and worker 1 actually 2 seconds. Worker the whatever the way it called actually, but anyway the context switching could have been happened. Yeah, it is this using the select statement. We are waiting for both the workers to be completed, and then we are coming out of that. This is about the select statement. Next is like next we will see how the rate limiting will work, right? Next is rate limiting. So rate limiting, so basically what we are trying to do is we are creating the limiter which allows two operations per second, right? And per second, basically we are trying to do six operations here, six operations per second here, right? So and also we are executing like a six operations here, and also here also rate limiting to 2 per second basically, right? Okay, let us see like how it works now. Operation 1 is started, operation 1 is completed, right? Correct. Operation 1 is started, okay. Operation 1 is completed, operations 2 started, and so on, right? Okay. So next topic what we will do is like a fan out fan in. Let us see that. Okay. So in the fan out fan in, what we are trying to do here is, so we are taking some input here, right? 1, 2, 3, 4, 5. And what we are trying to do here is we are trying to create a channels, okay? And we are trying to use the square by, let us see first of all what square is doing here. Square is actually what it is doing is it's trying to take the input values and output values. It will process all the inputs and it will multiply those things and it will give to the, it will just square it and then it will return it, right? So what we are doing here is fan out, like we are trying to divide this particular values here, and then we are trying to see this, adding these values in the result. Whatever the result we received, we are trying to print here, right? Let us see this one. Oh, sorry. Basically I'm talking about fan out fan in, right? So this is what actually we are trying to see here. We are splitting these operations and we are giving the operations to be executed in the square through the go routines, right? And we are trying to, what, how many channels we created? 3 channels, right? We are trying to make these channels and we are trying to fan in. Actually we are trying to combine these results. Basically we are splitting and we are combining these values, and we are in another go routine we are trying to wait for the channels to be completed and executed. One that is done, this out has all the results and we are trying to print that values basically, okay. And next one is basically content context package. We spoke about context package. Let us see that context. So this is very simple thing. Create a context with cancellation signal and we have long running operation, like in the default we are just trying to sleep for 1 second, and in the context is done we received, we are trying to cancel the operation, we are returning it, right? So we will wait for 5 seconds once this long running starts, and so we are expecting again this operation running should print 5 times, and we are trying to cancel this one. Once we cancel this, then it should be print like operation is content, like actually context is actually done, and we should return from the long running task, and then we will see how it ends this program, right? Yes, operation running, it should print 5 times as we discussed, and then operation should cancel and main thread is existing. That's it. And let us see like select with timeout operations. Next topic for us. So in this case, actually what we are doing is some slow operation we are trying to do. Here we are trying to sleep for 3 seconds. In the main function, we are creating one channel, and we are in the go routine we are trying to do the slow operation for this operation basically returns after 3 seconds of sleep. So we will wait for the slow operation with a timeout. Basically we are trying to wait for the operation to be completed in 2 seconds. Basically this operation taking 3 seconds, right? And then it should time out basically, okay. So what we'll do is go run main. So this is waited actually. So after the waiting of 2 seconds, basically it is coming out of the, because of this is taking more time, more than 1 second to complete the operation. So it is, timeout happened, it is returning back. Let us talk about next topic, and example is like a pipelines. Okay, so in this pipelines I have just taken generator one method, so that it will be generating the numbers and its values we are writing into the channel. And second one is we have taken the squaring of that numbers. Here just we see that we are again channel, we are returning channel by just squaring the numbers. In the sum method, what we are doing is we are trying to read all the input channel, I mean in the incoming channels, and we are trying to sum everything and we are returning it, right? So if you see the pipeline of stages, generator to the square and from the square to sum, basically like that. So generator basically we are trying to run all the nums, and this nums will be returning the gen channel with the values, right? This is what we are returning, and each value it is returning here. So we are going to read that value from the generator method, and that we are passing to square channel, square method as a input channel, as a gen, whatever we generated the numbers. And what it will do is it will try to return the one more channel with a squaring a number. Means that one means one square, that is one, two means two square four, like that. And this particular output of the square channel we are giving back to the sum method as a channel here again. Here actually we are ranging from the input channel, we are trying to sum all the values here. Okay, so the result will be we are printing as a result basically here, right? So let us see this how it works. That's it. Actually, if you see, right, 1 square 1, 2 square 2, that is 4. 4 plus 1 is 5. 5 plus 3 square 9, like 14. 14 plus 4 square is 16. 20 30, and 30 plus 5 square is 25. That is 30 plus 25 55. That's it about advanced concurrency